Jaja. Hi there everyone, I'm joined by mathematician Finn Barker today. He's a visiting professor from the University of Balamory, and today he's going to help me explain the Harry Potter question from the last test that we did. The reason that I've chosen this one to go over is because around about half of you got it, maybe not wrong, but perhaps not completely right, so it'll be a good one for us to go over, and we'll just clear this one up in such a way you can revisit it before we have the exam at the end of the year. The first thing we need to do, Finn, is get to the bottom of the screen. So just brace yourself for the journey to the bottom corner. Oh, good job. Toast.
No.
Oh, thank you for this gift. Great. This may be more challenging than what I expected. Finn is throwing interference. Okay, so the question reads, the book shown on the right-hand side has a height of 20 centimeters and a width of 12 centimeters. Within this book are margins that separate the text from the edge of the book. The margin at the right and left is X centimeters, whereas at the top and bottom it's Y. So your first job is to draw yourself a little diagram to represent this situation. It doesn't need to be it doesn't need to be an absolute work of art. So I'm just going to draw one of the pages as simply as possible. Like that. I'm going to represent the text with another box just down here, and I'm going to draw a few squiggly lines through it. Well, not squiggly, straight, to show that that's where the text is. So the height of that page is 20 centimeters. The width of it, going over the text here, but I hope that doesn't matter to you too much, width is 12 centimeters. And then the margin on the left and right is represented by X. Thank you, Finn. And at the top and bottom, the margin is represented by Y. Cool. So that's worth 1 out of the 4 marks. That's intended to be relatively simple and draw you into the correct working out for the next question. Thank you, Finn, for throwing your spoon at the tablet and scrolling down for me. Okay, so the question reads that we need to write an expression for the area of each page that cannot be printed on. So it's not able to be printed on. What it's getting at there is that it wants you to write an expression for the area of the margin. So this was worth 4 marks, and I'll show you how that is calculated. So part 1, we'll make it clear what we're actually doing and say the non-printable area. I'll keep that consistent. So that's going to be equal to, and you can treat this like a composite shape where that little area that's at the that you can't print on is going to be the same as taking the area for the entire page, but then subtracting the space in the middle that can be printed on. And that, of course, will leave you with the area around the outside that you are not able to be printed on. So that's how you treat this question. So the first part of that is to put in our dimensions for the rectangle that represents the page, so 20 times 12, so that'll give us the area for the entire page. The part with the writing on that we have to subtract is a little bit more complicated. So if I just highlight this blue part here, if we take away the area that can have writing on it, we don't know what the exact dimensions are, but we know that in terms of width, it's 12 subtract the 2 lots of X on the left and the right, because it's the margin for each side. That's our width. And our height is going to be 20 subtract the margin on the top and the bottom, so 20 subtract 2Y. Now, because it's area, when we multiply those two together, as in length times width, that will give us the area of that shape. So what we're going to have to do is put both of those into brackets. So length will be 20 minus 2y. That's our length, and our width is 12 minus 2x. Are you with me so far, mathematician Finn? Oh, great news, kiddo. So now we can start simplifying and expanding that, and thank you, I'm working through. So 20 times 12 is 240. So that's the first part taken care of. But you'll notice that when we expand these double brackets, and we do that by our normal FOIL technique, so first outside, inside, left, When we do the 20 times 12, that gives us 240 also, but because we have to take away everything that's in that the next expression, it reverses the sign. So 20 times 12 does give us 240, but we have to reverse the sign and make it a negative. So in effect becomes 240 minus 240 and cancels it out straight away. Next part, 20 times 2x is 40x, and really it's negative 40x, but because we've got to reverse the sign, that changes around again. So plus 40x. 2y times 12, negative 2y times 12 would give us negative 24y, but again we have to change the sign. All right, are you finished? Well, I better hurry things up. Thank you so much. And last but not least, negative 2y multiplied by negative 2x. Negative times negative would normally, bless you, give us a positive, but because we have to reverse it, that becomes negative 4xy. Yeah. Oh, are you getting a bit crummy? Dodo. Do you want some more beans? Okay, so cancelling off and finishing up. Thank you so much, kiddo. 240 minus 240 is nothing. That cancels off completely. And that leaves us with 40x plus 24y, thank you, minus 4xy. And that is your final answer. Cool. So we'll go over that a little bit more in class, but I thought it'd be handy to have a quick thing to refer to if you want to step through it a little bit more slowly at home. So it's goodbye from mathematician Finn. And here's 100 great ideas for gifted and talented teaching. We're going to read that right now. All the best.